Okay, just look at it. Okay, just look at this video. Just look at it. That is more than enough. Okay, I don't think it's possible. Now we can look at it. Okay. Now please look at it. Okay. Who is this? First of all, who is this?
Usain Bolt.
Usain Bolt, right? So now, look at this video very carefully. That is what the concept comes. Okay? Okay. Now, he is ready to run, right? He is ready to run. So look at very carefully. Okay? Now we can read the sentence which is available at the blue color. Usain Bolt was slow to come off the blocks in the opening exchanges, isn't it?
Yes.
He was very slow. Remember that word. Usain Bolt was slow to come off the blocks in the opening exchanges, right? But as the time runs, as the target is very close, you can look at how far he is running. He made up for a last ground in the final 30 meter to bring home his third Olympic gold medal. So what you are understanding through this video is, first I ask you, what you are understanding through this video? Did you watch the video completely, right? Yes?
Yes.
Now?
Yes.
Okay. Now, let me put, instead of putting that in terms of the letter, right? So let me put that in terms of a graph. So graph is very easy for you to interpret the things, right? So let me put down the values here. This is your distance. This is the distance. Okay. So let me put down, this is the distance. So how much distance he needs to cover it? And this is the time, right? So time versus distance. So how much distance he covered so far? How much distance he covered? I mean, he wants to cover every day.
100.
First day, 100, right? So this 100 meter, he needs to cover it, right? So first day, tell me how much time he took.
How much time he took?
10 seconds.
10 seconds, okay.
Isn't it?
Yes.
Right. So now let me put it like this. So 10 seconds. Right. Okay. So now this is the starting point. This is the starting point. Now is that value is what? How the curve will be looking like? Will it be like this? Will it be like this? I mean, he goes slow, and finally he reaches his destination, isn't it? Will that be curve is like this?
Okay.
Is it a straight line? Is it a straight line?
Yeah.
See, is it a straight line? Now the one which I am drawing is a straight line. But actually, it is not the correct response for the video that what I have shown. Why? Because of that, in that video, Usain Bolt, right? Bolt is there, right? Bolt, immediately he ran very fast, isn't it? Or slowly he picks up.
He slowly picks up.
Slowly picks up, right? So what I am going to draw is the curve let me draw it in a different manner. That means earlierly Usain Bolt took some time to settle on it, right? So during or 1 second he didn't move at all, right? So there is a change. There is no change in him, right? So after that, slowly he's running, right? So finally he reached the place, right? So again at the time, see now this is your 10 second, right? So during 9th second he turns back, right? He turns back whether anybody is near to him, right?
Yes.
Anybody is. So when he wants to reach the target, still his speed is increasing or still his speed is decreasing. Obviously, if he knew nobody is near to him, obviously his speed is what? Reducing, right?
Yeah.
So now here also some slope will be there, right? So here also some, distance is what? The speed is reduced, right? So now this is what the actual curve for the video that what I have shown to you. Okay. Understand what I am telling? Okay. Now the picture is very clear. Okay. Now tell me what is the meaning of gradient or slope. Yesterday also I have told you what is the meaning of gradient or slope.
It means how to say this
Ratio between
run over
Rise.
rise.
run over rise or rise over run.
Run over rise.
Rise over.
And rise
Rise
over
over
run.
run over rise.
Rise
Tell me.
over one.
First, what is the speed? Speed equal to what? Distance over?
Time.
Very good. Distance. Here we have measured, here we have marked distance in y-axis or x-axis.
X.
Hey, distance is this.
Distance.
Oh, Y.
What about time?
Oh, X.
X-axis, right? So now tell me whether if you want to see from this triangle, this one, right? This slope is nothing but your triangle, isn't it? Right? So let me change the color so that it is right. So what is this slope? Slope is nothing but your triangle, isn't it?
Yeah.
Slope is nothing but this is for triangle, right? So here for this straight line, slope will be like this. Okay. This is what the slope I want to estimate, or gradient that I want to estimate. If you want to find out what is the gradient or slope, then you have to use the formula. Whether you have to find this speed, distance over time or time over distance for the slope.
Distance over
The
time.
right angle triangle is forming, right? You know how the right angle triangle is forming, right?
Yeah.
So right angle triangle means here 90 degree, right? So now tell me, here rise over run you have to put, or run over rise you have to put for speed. For speed, we have to put rise over run, distance over time or time over distance, Okay?
Distance over time or time over distance? Distance over time.
Very good. Distance over time. So that's why so here speed is nothing but the value. Speed is nothing but gradient. Instead of distance here, what I am putting? Here, instead of distance, what is there? It is there in the rise, right? So rise. Instead of time, what is the value? He ran, right? He ran at the particular time. So can I put rise over run? Is it understood for you? Don't forget it. Don't put run over rise. Okay?
Okay.
Always you have to remember rise over run. Last class also you might have asked this question, no? Why the gradient you are writing rise over run, sir, instead of run over rise? Isn't it?
Yeah.
Did you ask or what?
Yeah.
Right? The answer is here. The speed equal to what? Distance over time. So that's why I am using rise over run rather run over rise. Clear? Clear to you? Yes?
Ma.
No. See, you have asked the question in the last